Right, so it's 6 p.m. or 7 p.m. now. So let's get started, and anyone else can join in as and when. But hello, everyone. Welcome to the Golang Live webinar, a tour of the GRPC ecosystem using Golang, part of our live series here over at Amicus Recruitment. My name is Jake O'Regan, and I'm a specialist Golang recruitment consultant here at Amicus, specialising in supplying Golang development professionals to companies in Berlin. As a company, we do also focus on London-based companies and roles also. I'm excited to be hosting what should be a very good, very informative webinar, and also being excited to be joined by Sudersen to pass on his knowledge and experience in this field also. It will be interactive, so don't be shy in asking any questions using the Q&A button below, but Sudersen's also allowed time at the end to answer any questions also. We'll try and keep it to as close as an hour long as possible, but other than that, it's over to you, Sudersen, to introduce yourself.
Thanks, Jay. Thanks for this opportunity. Good evening, guys from Berlin. We are today going. I work at Omio, obviously, and I have been developing Golang for more than 4 years now, and a lot of things I have done. So today I'm going to talk about GRPC ecosystem in Golang mostly. Just at first glance, GRPC ecosystem itself is very generic. So if you're not from this Golang background, this is a stuff for you as well. And there is quite a bit of things for you if you professionally work in Golang. So let's get into it. What is GRPC? GRPC is expands to GRPC Remote Procedure Call. It's a recursive acronym, just like GNU. So there you go. So if you're still wondering what does G stands for, it's also an open source project from Google. So there you go. There is a hint for you. And it uses HTTP2 as transport. It uses protobuf as interface definition language. So if you have this HTTP2 as transport, protobuf as interface definition language, that's GRPC. It doesn't allow any other message formats. There's no JSON, there's no XML, etc. There's just protobuf. And for transport, you're going to use HTTP2. So this is how it is. What are the other technologies? We have the REST, which you might be familiar about anyway. There is SOAP, and if you're still stuck in this ancient era of Corba, that's the one. There's a special mention for that. So let's get into the pros of GRPC. The first and foremost would be the benefit itself comes from the technology choices it makes into the system. The first thing that we mentioned was it uses protobuf as the interface definition language. So there is one benefit that you get out of protobuf is that you get fast relation and deserialization. Why so? There are careful design choices which are made, which we can get into detail in later part of the slides. Because of that, it's much faster than this. Also, the protobuf is contract first. So you have well-structured schema, and there is a lot of leverage which is exploited out of this feature. And that's why it's faster than JSON itself. In JSON, you don't have a schema. You can pass on anything you want, and it comes with a passing cost. At the other end, there could be simple screw-ups, which could be like adding spaces in JSON, could add up to your payload cost and also the marshalling cost with it. So it just adds up. So this kinds of silly errors are not possible with protobuf. That's why it's very efficient in terms of marshalling, unmarshalling, and with the network cost. The third thing is that it uses HTTP2. It mandates it. There is a very significant amount of web traffic and APIs written in HTTP1. But there are a few benefits which I would like to boast on for the HTTP2. One is that it has this header compression. If you're sending headers, HTTP2 is efficient. It also allows you to multiplex multiple packets over the same TCP connection. So it utilizes this TCP connection to the best compared to HTTP1. Then you have other sorts of benefits in that line, as in like you have server-side push, etc., 100% binary encoding when it comes to the protocol transmission over HTTP2. So added this benefit combined with protobuf, you get the best of two worlds into one, which is GRPC. Apart from that, it has a support for dozens of languages. Most of them are very popular languages, be it Java, be it Python, be it Golang. So it supports most of the language that you're using for. If you're still using Haskell, good luck. So there are no supports for very ancient languages. So yeah, that's one of the drawbacks I would like to put with this system. And then, as I mentioned many times over the last 2 minutes, that it's highly customizable. It has an excellent support for middlewares, which comes in-house. You don't need to look for anywhere else. You just need to look at the ecosystem, and it's available in every language possible. So these are the pros. And apart from the benefits that I mentioned, just as a part of ecosystem, it supports 4 modes of communication. One is you communicate from the client to the server, client to server interaction, which is the normal REST interaction that you get. For example, you can make a GET request, POST request. That's a unary transmission here. Apart from that, you have server talking to the client over the streaming, and client talking to the server over streaming again, and then the bidirectional streaming. So all these 4 modes of communication are available here in-house. If you take the REST mode of transmission or the normal HTTP mode of transmission, there are many workarounds, but again, they don't come in-house. You have to go away from out of the box and do all kind of tricks to make it happen. But here, if you're developing some kind of a streaming application, GRPC would be your best choice, given that it has more efficiency and the streaming included without you doing anything there. So yeah, that's one. So let's get into the difficult parts. What could be the con? No system could be perfect. There are obvious drawbacks with the system as well. So one of the things is that it's not supported by default. So you download this Golang, install it in your system, and expect that HTTP is there, right? But GRPC is not there. But again, I don't see it as a biggest drawback here, because you can always get this library imported in and it should be working fine. And all this library is going to do is that it's going to generate the code in the platform, in the language that you want it to generate. So there is no extra added cost of this library itself. It will generate the native code of that language, and you get the benefit out of that. There's no translation, there's nothing. It's just a pure language code that you're dealing with here. The second drawback, which could be pesky if you're starting to use the gRPC, is the status code. There are, I think there are 15 to 16 different status codes which are defined by the gRPC ecosystem, but they are not very strictly followed. So it could be code 0, code 1, code 2, till code 15, but they are not strictly enforced. It's easy to mess up there. So status code is something which gRPC is lagging right now. So let's get into the basic gRPC 101. What does a gRPC? What does it involve? Working on gRPC, or what does it involve to get this gRPC into your system? The step number 1 would be define it. You're going to define the contract. It's contract first. So first thing is define the contract, then compile your code in the choice of your language using the contract. And the third phase is, so this compile phase is going to generate the client-side code and the server-side code. So this architecture, the gRPC architecture, is a server-client architecture, whereby you will have a server-side code, and that code will contain all the interfaces that you have to implement and set up your server. And at the client end, you're just going to talk to this server using its coordinate, host and port in most of the cases. So there are these 3 phases you have to go through to develop this system. So let's get into a simple demo and what it takes for you to write your first gRPC application. So here it goes. So first is define the contract. How do you define the contract? So as I mentioned before, for interface definition language, we are using protobuf. And the protobuf, it follows the similar format given by the protobuf system. You are going to create a .proto file, and there's where we are going to define the contract. So let's get into dissecting what does a dissecting this profile. So given on your screen is this profile. The first line is syntax equals proto3. What does it mean? It means that the profile that you're writing is belongs to proto3 format. There is proto2, which is not compatible with proto3, mostly because there are many changes that went into proto3. So this is recommended that you use proto3 as your syntax definition. So going to the line number 3 next, this is option go package equals to talk20. This is an optional parameter. Your profile would very well work without this line. Just that it's recommended that you supply the package name. So what does this package name mean is that once this contract gets compiled to Golang, the package name would be talk20. And in case you want to have the name static, you might be generating this code elsewhere. So if you want to keep the folder name intact, package name intact, this is what you're gonna use. If you don't supply this, it's going to pick the folder name where you compile it. So that's why we have put this line of code here. From the line number 6 to line number 9, we have the service definition. It just, the contract needs you to tell what does a service look like, what are the methods it's going to contain. Just like you're going to write any other service, and there's where you're going to define different methods. You have to define the methods. Right now, we are going very simple in this case. We are just going to write a read endpoint which takes in request and which returns back the response. This is all the service is going to do, but you can have n number of methods. So the key difference that I would like to point out when it comes to gRPC versus REST is that REST has 7 different methods: get, post, etc., yada yada, and you have to follow those conventions. But here in gRPC, you have a full flexibility to choose the name whatever you want. That's all, simple. So here, the method that I want to call this method is read. It takes in request, it returns back the response. So this is all this method definition for this services. And if you can see, the request has one parameter, which is ID. You can have n number of different parameters going on from there. For this simple example, I have just picked one single string named ID. If you're a little curious, what does this equals to 1 mean? It goes on to the, it's because it's the way protobuf is defined. So let's get you to a bit of architectural aspect of this protobuf. Protobuf is, you can imagine it to be like an array. And in this array, you'll have first ID equals to 1 as the first element, ID equals some XYZ equals to 2 as the second element, something yada yada yada, stored in that index. So it operates in this way. It's sort of an array. So why do they store it as an array? Because you have defined a contract. This is the array which a client is going to maintain, and there will be another array which the server is going to maintain. And when the talking happens, they're just going to transmit index 0 equals to this, index 1 equals to this, if it is set. So in this way, the talking happens based on index, and the other end would totally understand what does this index mean. So because of this thing, you have to define what's that number is. So the added benefit of this thing is that you're only transmitting the value. You're not transmitting the key at all in this case. So why protobuf over gRPC is very efficient? Because protobuf in general is efficient, is because it only transmits the value. It never transmits the key. Key is kind of redundant and taken out of the equation. So there you go. So next, and again, one more thing that I would like to point out about the protobuf numbering is that you have to pick the minimal number available. So let's say I want to add the next field, string ABC, then I would number it 2. Why so? Because just going back to the point of array, when you have an array, it would define to the size of the maximum number that you have put there. So let's say at the first glance, I put string ID equals to 100. It's going to create a 100 array, which is pretty inefficient, right? So the next, that's why we have to pick the next minimal index. So you might be curious, What about I deprecate this field called as an ID? What happens to that ID? So if you're choosing to deprecate some point in the time in the future, this ID, you are never going to use that index 1 anymore, because there could be different compatibility issues. Your server might be thinking ID is this. If you try to reclaim that, you might have defined something else here, and that could just cause a contract breach. So the best approach here is that if you're choosing to deprecate any field, just leave that vacant, move on to the next minimal one. So this is one of the points that you have to keep in mind when defining a protocol of contract, is that you're gonna choose the ID and make a wise choice that you're never gonna use that ever again. And same goes for the response as well. So this is all it is. So if you take a proto file, and if you're writing a GRPC system, there are these 5 things you have to take care of. One is the syntax, one is the package name. Then you're gonna define your service. What does your service look like, and what are the methods you have? You can kind of put an analogy to this one as the interface definition that you're gonna put. You have an interface, you'll put different methods, you'll say what input it takes, you'll say what output it gives out, and you just define the request and response and all the structures you want. That's all. That's all the proto file is all about. Moving on to the next step. Next step is the compile step. And in this compile step, you need this library called as proto-c. This proto-c library is very highly customizable. You can add in tons of plugins of your choice, available on just open source. Most of them are open source. That we'll get into the details about it in advanced slides. But right now, let's focus on this syntax. The first is the proto-c library, which you require to be you are required to install on your system or whatever, wherever you're trying to compile this. The second part of it is the proto path. This proto path is simply the whole relative or absolute path to the directory where your proto file sits. So that's what the proto file indicates. Then the third is go out. Here we are working on Golang examples. So I have chosen go out. For Java, it would be Java out equivalent, something like that. So this is the parameter which says which language your code is going to compile to, which language specific code this compiler is going to generate. And then followed by finally finishing off with the proto file itself. So this proto file, which you are seeing on your screen, is sample.proto. So that's all is all the compile about. And it's going to generate a file something like this. These are the initial line. It's pretty big, so you don't need to bother about what's into this file. All it's going to do is that it's going to generate tons of things required for your gRPC service to run, and all in this all generated code, the point of interest would be the interface itself, which you're going to implement at the server end. So we'll get into the details of it now. So if we peek into this code, we are going to see 2 interfaces which we are kind of interested in. One is the server interface. This server interface, if you can correlate, it's this is a Golang code, so it's going to generate an interface definition. First, it's the server sample service code. It's going to just name the interface, and then followed by the read. In read, it takes in the context. This context is the same context that that the Golang has, just a context library. And this request is the request object that we have mentioned here. So it's going to generate a Golang equivalent request object structure, and that's what we are referring here in request. And then in the response, we have some the same equivalent which we have defined in the proto file. And then finally, we have the error. We are going to use this error as a medium to transmit some errors or mishaps that happen in this. This is the server interface peak that we have. The next one that we would have is implement the server. So this is the interface of the server. I'm seeing a Q&A. Just let me read out if you have any questions.
Yeah, just one question come through then from Andre Sudersen, if you can see that one.
I'm not able to see that somehow.
Okay, so Andre's put, is the GRPC only good for service-to-service communication, or do you also use it for requests from client devices?
I would advise that's also advisable to request externally as well, because right now a lot of Google libraries are moving to this gRPC setup. For example, if you take AdWords and those endpoints, those are in gRPC, and many firms are moving towards the gRPC communication. Yes, you should be really doing that, because in my last organization as well, we were considering that option and actually moving towards gRPC communication because it gives us more benefit. Yeah. You're right on that.
Thank you. Hope that answers, Andre.
All right. So so this is the interface definition that we have. We are just going to implement this into our code. So let's move on to that part. So we are going to implement this interface, this server interface, into the code. The first 3 lines, line number 11, 12, and 13, are just the way you're going to initialize. This is just a new method that we have in Golang, where we generate when we create the server object. So totally irrelevant line. So this is the meat of the definition. First part is where we're going to put in the structure of the server. Here in the structure, here I have just picked a very simple example. But however, you can have this structure having all the dependency injected into the structure and just initialize it once. Highly recommended you initialize just once, put in all the stuff you want into the structure. Here I picked a very simple example. It can be elaborated as much as you want it to. And then we are going to define this exact read method that we are looking at on the other screen. We are going to take in the context, then we are going to take in the request, we're going to respond, and we are going to put the error. Again, I put the very simple example here. This error equals to nil is just a very new way of doing it. Of course, you should be handling errors and transmitting what you want at the other end. So don't take the inspirations from here. All right, so moving to the response part, this server is a very simple server that I have implemented for the purpose of demonstration. We're just going to print the server time and then print the request ID in that. That's all. So this is a very simple gRPC server. So let's move on to the client peak. So client interface looks very similar to the server interface, but just the main difference is that the client is going to supply the context, then the request, and there are tons of gRPC options that you can supply. Most of them are pretty not needed, so that's why it's an optional parameter. If you really want to get into the customization, if you really want to convey a few extra bits like headers and etc., you're going to put it into the options and send it over. And you can also very well use the context as well to define your headers. And you're going to get the same thing as in the server, response and error. So this is the interface definition. Key thing to note is that we are never going to define anything in terms of server. We are not going to define the server interface. Server interface is something like this. One thing, we'll get into the details in the next slide, but you never implement any of those things. That's all you need to keep in mind right now. So a client side would look something like this. It's not an implementation, it's just the connection to the server. So the first line that we look at here is that it's going to connect to the server and port. One key thing to notice here is that you always need to have some kind of a server and port associated with gRPC ecosystem. I'm not aware of any of the setups where you don't use the port, but maybe there could be workaround. But you gotta supply this gRPC endpoint first. I picked the insecure here, but there are many security parameters and configurations that you need to do at the other end to make this happen, but insecure is the easiest one to go through for the demonstration. So yeah, highly recommended if you're using any external system, go with the secure ones, follow all the recommendation that the gRPC ecosystem gives. Then, very poor way of handling this error, but yeah, only for the demonstration, you are going to log any error that comes in during your connections. Yeah, we have another Q&A.
Yes.
Somehow not, yeah.
Okay, so yeah, Can you see that, Sudersen, yourself?
Somehow I'm not able to see that. I'm able to see the prompt saying Q&A.
No worries, that's fine. I'll read it out to you then. So this one's come from Mahmood. When the schema involves, you have to generate client and server again and distribute the code to all clients. What is your advice to make this easier?
So let's say you change the proto file and you want to generate the server and client code again. Is that what you mean? I didn't kind of catch.
Well, I'll read it out one more time. So just repeat it. So it's, oh yes, he's just replied yes.
Okay, every time you change the proto file, do you need to generate the client and server code? Yes, you would be required to, but it's just one command. You can save it anywhere and just rerun it. It's gonna re-render it. So if you change the contract, you're gonna generate the code. Of course, Protobuf gives you a way to keep it backward compatible. It's pretty easy. You just ensure that you don't mess up with the already existing index and just move on to the next index if you're adding some fields. That's all. So every time you change the contract, you are required to generate that code again. But again, it doesn't need to be in tandem. Your server code could very well have some other version of the contract running, and your client code could very well have the other version. Just that ensure that while you implement, you keep it backward compatible. This is the general problem that you're going to face anywhere. Like you go for REST, you're going to face that. You should not mess around with the same field. So it's the same deal. Keep it backward compatible, generate the code on the server, and then roll out gradually to the client, and it should work fine.
Perfect. Thank you, Sudersen. I've got one more for you, just whilst we're on a couple of questions here. How does GRPC deal with retries? Is it automatic from the client to server, or do we need something really specific?
Retries, as far as I know, there are some retries which are in-house, but there could be some more which you can add on top of it. But I don't know much on that. I'm just aware of that fact.
Okay.
Some
Perfect.
basic network retries are provided, but it's pretty generic problem to solve. So some basics are provided, some you can try on yourself.
Okay, thank you very much.
All right, so let's dissect into the how do we connect from the client to the server. The first line is the connection itself, where you supply the coordinates where you're gonna connect to the server. Then this is the CLI that we have. This new sample service client is provided by the code itself. So we are just going to supply the connection object, and ta-da, our client is ready. And then these are the prerequisites that we have to do to make a call to the server. One is the context. In this context, there are tons of things that you can put in, sneak in, and let the server understand what you'd really try to make. So here I'm using a context as this is a timeout. You can very well supply different SLA parameters, and your server would understand that. And there could be some meta information passed through the context itself. So here we're picking a very easy example of keeping a 2-second timeout. And then we have the request. We're building the request object, and then we just firing the request. That's all. So one thing to note here is that one key difference that we, at least from the Golang perspective, is that we don't need to deal with the marshalling here in this case. It works like any other object in your code. It happens that this client object is talking to a remote server, but it works like any other object in your system. So just to put a stress on that, you're just going to supply the context, going to supply the request, get the response and the error, if any, handle the error, don't panic, of course, and then go on to just print the message. This is all the client code look like. So one recommendation, this client connection, make it singleton as possible. Don't initialize it with all the reads and those things. So yeah, this is the one thing. Moving on to the demonstration part. So we're gonna run this code, in fact. So here in this setup, I have kept my server. This is the server definition. This is a very simple server definition. First thing is that this line, and all these 2 lines, these are part of any gRPC service you're gonna write. First is the server. You're gonna create a gRPC server, which would act like a stuff for your server. This is the definition that we have provided. This is our server. We are writing a sample server. This is what it is. So if I go back a couple of slides, this is the method I'm trying to call. Use sample server. There you go. So this is this service we have written. We are going to sneak in this service and this gRPC server and register it. For your service, you can have multiple gRPC services and also stuff into this same setup. So you're going to add register sample service server. So this method is provided by your code that you have generated. This is from the code. So it's going to generate a file called as .pv.go. It will have this method. So you're going to register your service. If you have another gRPC service in the same application, you can very well have another one and register it. And then we're going to set up a listener on one port. The port, you can choose any port that you want. It's all the TCP, of course, no UDP. Sorry, guys. And that's all. We start the server. That's all. We start serving the server. That's all. You have to do a couple of bindings, just like any other service, and we're good to go. And from the client end, for this demonstration purpose, we are starting the server here. This is our client code. We're connecting to the server. It's my local host. So this client code was the previous code that I've shown. I just done some initialization stuff to connect to the server, my own local server. I build this request parameters, and we're gonna fire this request to the server. So we're gonna run it. I'll just show you how small run would look like. So our server has started here. Our client has connected to the server that we have started. And then if you can notice that we are actually doing a CLI.read. So this read would have some response. This message reply is the current time. It's a Berlin time right now here, 7:32, and that's what it's going to respond. So this is how a simple server client interaction looks like. It's pretty much same as the REST one. So yeah, so at this point, we have reached a point where we have written a very simple service using this gRPC system. You define the server, use your client to connect to the server. That's all. Do the talking after that. And let's get into, yeah, we have another question. Would you?
Yes, no problem. I'll read it out to you.
Thank you.
Okay, so whether gRPC follows FIFO for message consumption, any priority can be added to these messages?
Okay. I'm not sure about the priority factor. Not sure on that.
No problem. We'll come back to that one at the end then, if possible. Okay.
All right. So let's get into the other discussion. Let's say you have a service already written into this REST, mostly the HTTP GET, POST, and etc. And how do we migrate it to gRPC? I've done this in past, and based on my experience, I'm going to share a few bits of how do we do that, and how do we keep it running, in parallel, where we have this HTTP and gRPC in parallel, and then gradually roll out the HTTP out. If you wish to, highly recommended you should do that. If you are actually at least interacting within your organization, if you're talking between two services, it does make sense more to keep the gRPC talk, because it looks more of, from the core point of view, more of looks like some object you're trying to access just within your core. You don't need to go into the network details. So it keeps the core clean, it gives you the efficiency. Highly recommended you talk gRPC at least within your organization, and you should be highly recommended that you should be talking outside as well, because it gives you tons of benefits of starting from HTTP2 itself. So let's get into the details of it. From slow moment. Let me play this. All right, this is GRPC gateway. We're going to use that. All right, so we are going to use the GRPC gateway. That's one of the methods that we can use in, at least in Golang. It has a supported ecosystem. I hope that should be having an equivalent for other languages too, but we are going into details for Golang here. It's very Golang specific, at least. So how do we do this all kind of stuffs? First is it's the same drill. We're going to define first. We have a sample service and it has a read, but wait, there's a little bit of change here. That's that we are going to add options, and we'll get into a little bit of details in next slide. So what this option means is that for this read method, I'm going to have a get equivalent. It will have this path with read and then followed by ID as a parameter. So this is in gRPC terms, it's called as an annotation. We are annotating this method for the HTTP REST equivalent. So this REST method is a get /read / some ID that you supply. That's all. So let's get into how do we accomplish this thing? How does a proto file look like? And what do we need to do to make this happen? So let's look at this proto file. It has some bits of new things added compared to the previous one that we discussed, the vanilla server to a next flavor server. Let's dissect this. First line is proto 3, same drill, protobuf 3, that's what we're using. This is the package name as before. What are these two things? The first one is annotation.proto. This is for the gRPC gateway that we have. We are trying to annotate it. And this is a library that we're going to use for this annotation. For this annotation, we kind of need to import this library. And the next one is the validator. This is not a part of that. I have just added this for just to give you a glimpse of how customizable the gRPC is. So we can have tons of validators. This is just an example. You can have tons of different things available online. You can plug into your system and use that library as a part of your service. So I think I went through the description of what does the service look like and how do you annotate it. You annotate it with this ways. And let's look here. This looks interesting. What is this JSON equals to ID? Why do we need to have it? So in gRPC gateway system, when you come to gRPC, the interaction happens in protobuf. But when you want a gRPC gateway, when you want a HTTP equivalent, the talking happens in JSON. So it's fair to say that you're using JSON when it comes to HTTP interaction. If you're choosing gRPC gateway as a method. So just to define, now you have a bit of idea of what's happening here. So gRPC gateway is sort of a translator for the existing gRPC service. The gRPC service is going to start in the same way as it was before. Just that you're going to add this gateway, you're going to generate those codes. It's going to listen to this gRPC gateway, do the translation work if you're trying to interact over to the HTTP. We'll get into more details in coming slides, but let's discuss on what is this JSON name equals to ID is. So this JSON name would be the JSON name that we have chosen. If you don't choose that, it would actually pick the name which is here. So normally in protobuf, the style of naming a variable is using a snake case, having ID underscore ABC underscore XYZ, something like that. And if you don't want those names as a JSON equivalent, this is an option you're going to use to override those things and use your own name. Let's say your name contains other non-variable characters like colon or something. Better supply this JSON name, and when you marshal the JSON, that's the name which is going to get picked. And just to show a demonstration of the different tons of library that you can use, here we have clubbed in the JSON name. One thing comes from this annotation library, and then the validators annotation as well. So this validator that I have chosen here actually checks if this field exists or not. If you call this validator in your code, it's going to check for you. It's going to generate all the code that you need to do those checkings. You don't need to write it. So this, so in nutshell, gRPC generates different code so that you don't need to write it. Those are the redundant things that you kind of have to exclude to make pace of your development pace. So yeah, these are the different changes that we have when we get into this gRPC gateway. So what does a compile would look like? Don't be scared. This might look very intimidating, but I'll just boil it down for you. Let's look at this example. This proto-C would go in two phases. First phase would be generating a .pb.go file, and then we would generate .pb.gateway, which is gw.go file. And this pb.go file is business as usual. It's going to generate a protobuf Golang file, and then pb.gw.go file would actually listen to the already existing gRPC port and do the translation work for you. You don't need to know what's the internal database. It's just going to generate those codes. So I'll just quickly go through what are the different parts of it is. First is that we are going to import different dependencies to make this really happen. So one of the dependencies is, this is the current directory. It is very, it's the equivalent of the sample that I used in the previous example. Then we are going to use this boilerplate. This is a specific boilerplate for the gRPC gateway. So this is what we have to include to make this work. And it's pretty much the same. We are going to do a G out. In case of Java, we're going to use the Java out. And this is the proto file for that. The second step here, so this has to be in the sequence. First, you're going to generate pb.go file, and then we are going to generate pb.gw.go file. So here, these are the common syntaxes. One is that we need the proto directory. We need to include the include of the system. It has tons of dependencies to generate this file. It works on the network, so it needs these things. Then we're going to go through the boilerplate. And then this is very specific to the gRPC gateway. Here we are going to supply different customization that we want to have. And then finally just apply the gateway file. And this is going to take care of generating those files. Again, it's not pretty hard. It's just one Google search away and plus a couple of trial and errors to get this code generated. So in compile phase, it's going to be a bit sophisticated, but once you get it done, once you get the command, it should be blaze. Moving on to the same drill, the third phase, we have entered the third phase. Here we are going to implement a server. The server is just basically the same thing. Nothing changes here in this server part. You're just going to implement it in the same way as before. No changes at all. Your application doesn't even need to bother whether you are using the HTTP gateway, whether you're exposing through HTTP or not. Only it just decouples it. Your implementation has no idea that you're going to expose it to some REST port or HTTP for JSON like interaction. And let's go into details. How does this setup work? So here we are going to run this server. I'll get into the details, what changes from the server point of view. Not much changes from the client point of view much, but let's get into the details of it here. So here we are defining the server. If you remember from the last example, these 4 lines are just the same thing. We are having this gRPC server. We are actually instantiating this service, the gRPC gateway. It is the same thing as before, nothing really different. We are registering it. Then we are going to set up a listener for our gRPC port. Yeah, and then start it. So the first step we're going to do is that you're going to initialize this gRPC port and start it. Done. So only after you start it, we are going to attach the HTTP over it. So this HTTP, I have written a small attachment code. We'll get into the details later, but what it what it takes is that it's going to take the GRPC, it's going to match it against the rest. That's all. And you'll have separate ports, 2 different ports, one for GRPC and one for the REST or HTTP. And then we are going to start the HTTP server. That's all. And if you note, this is how we're going to start here. We are picking this server. We're going to start the server, do all the, we're going to match the REST or the gRPC. And here, if you note, this is the difference. We are actually talking to this gRPC port or HTTP. We are actually making a GET request. This doesn't mean that we are only exposing through REST. You can very well have your own client, just like we described earlier, connect to the gRPC port, and it would work fine. So this service is full-fledged for gRPC and HTTP now. It's on both. And this is to ensure that your existing HTTP service can move to the gRPC one. And till that point, you can define the contract equivalent to the current HTTP setup, have it both running for some time, decommission the HTTP. So this is all it does. So let's try to run this, how it looks like. So if you note this first 2 lines, I tried using the same name for the next objects. Do not use the same names. I use the request here. I have defined the next profile, gateway.proto, and use the request itself. So highly recommended use as different names as possible. Do not use the same names in 2 different profiles if you're writing in the same application. And then what we can see here is that first gRPC port, gRPC service starts on this port, and the REST port attaches on that gRPC port. And here you can see that the interaction is in JSON here. And we have a reply saying a string that this is the current time here. So this is a JSON interaction. So yeah, this is how it is. So this is how you can interact with gRPC service or JSON and those REST HTTP protocol. So moving on to the gRPC to HTTP converter and what is it about and what does it do? Here, first thing, if you notice, is that this is the whole part of the converter is. Here we are going to initialize the MUX. MUX is the HTTP server that we have. We don't have a lot of choices, but this is pretty efficient. We were able to support, in my experience, we were able to support something like 200 requests per second kind of scale using just this MUX, which converts to 12,000 requests per minute kind of services per node. Using this MUX, this is pretty efficient. It's no lesser than other things. There are many, there could be little differences, but this works just fine. And here we are just going to, first, if you notice this, it would use this gRPC address, use this gRPC address, and then use this REST address, do just this little initialization you have to do to make the conversion happen. And we are going to start the HTTP server here, just like not much different than the original HTTP server that we start. We have to add the gRPC address, throw in a bunch of initial DAT options and etc. And it should work. That's all. This is a little converter that we have to do. That's all. So this is what gRPC to HTTP is like. So there are a few recommendations I would like to give when it comes to this. First is that if you, this is one validator I would like to boast for, is pretty good, but you can have other validators too if you feel that it's good. Always have some kind of a validator or gRPC if you're using Golang, because there are tons of ways where the objects could be nil and those things, and you kind of want the validator. And one very important thing I would like to point out is that you always use JSON PB library that you have with the gRPC itself. If you use JSON Marshall or something, it won't work. Precisely because, let me point you out to one point of code, which is very important, why you should be using JSON PB. So JSON name equals ID. This convention would be only entertained if use the JSON PB library supplied by the protocol of Golang. If you don't use it, if you use JSON Martian, you're gonna face a trouble here. So yeah, highly recommended use that JSON Martian for the time being. And there are other equivalents as well, but this is good enough. It has a good support. Use the one which is supplied by this. So that's one clear disclaimer that I would like to give if you're operating on GRPC gateway. So yeah, here I would like to talk a few words about the application that I used in my project, in my production experience, and how it went. So we had an application whereby we had to, I was working at an e-commerce service, e-commerce firm, and where we had an application of delivering the content. It's a huge payload that we had. We had to deliver it in scale. We were having a sale in coming few days and like a next month or something, and we had to make it efficient because we figured out that current HTTP server our service doesn't work that scalable because there are many choke points that we noticed. And also we were actually facing problem with the contract itself because we're delivering the content, it has contract, and that contract nobody had a clue. It's hard coded in the code, and the product managers were just scratching their head, what should come here and what are the fields which are optional, what are the fields which are mandatory, and those things. So we didn't have the contract in the first place. And second thing, we were also facing the bottleneck issues. So we were doing a bit of searching and figuring out what could be done better or optimizing over the current things. But we came across the GRPC system, and then the first thing that we were amazed that we were able to set that whole hard-coded thing into a contract which the product managers, non-tech people, and us can all see and understand. So that was a one pro that we got. The second thing was that so our service was obviously in HTTP. We also wanted to make the code easier to read because we didn't want to do this marshalling stuff and confusing, handling the status codes and yada things with it. So that's one thing. What we chose to do was replace that HTTP server with the gRPC and keep the HTTP server running in simultaneously for the time being, and then decommission it as we go on. So the clear benefit that we got just by replacing this HTTP with gRPC was we got a reduction of 20% in the response time, precisely because the marshalling cost was down. The second thing was we had a lesser exchange of data over the network. So it also improved the bandwidth usage. It also improved the usage, this thing, and a little bit of React that we did. But again, just changing this gave us this much of benefit because we were using the HTTP, we were using protobuf, and we got this much of reduction in our system just by using this. And yeah, that's all about my experience. And yeah, this is a wrap now. Any questions that you might have? This is the time.
Yeah, let's see if any questions
you would like to download this presentation, I have pushed it to this repository. You can go and play around with the examples that's in there. It's the same setup. You can add some fields and try it out. Yeah.
Perfect. Okay, well let's see if some questions come through then, Sudersen. Also, guys, this whole webinar will be recorded and posted on YouTube. So there'll be ways of contacting you that we can send it over to emails, LinkedIn, anything like that if you do want to have a go back through and run through it. But one question that's just come through here, Sudersen, is performance-wise, Gorilla MX Router REST API versus gRPC, which one is better?
Gorilla works in HTTP, right? So gRPC, so I mean, I would not argue because you can very well use Gorilla Mux or protobuf and get the benefit as well. The whole point I'm trying to make here is that with gRPC, you get it in-house. There's no guarantee that you'll be using HTTP2 in Gorilla Mux. There is no guarantee that you're going to use protobuf. So why not use just gRPC and get the benefit? So it may not be that different, but again, it could be big different when it comes to performance. When you're hitting a high scale, it could be different. Yeah, it could be better in gRPC case, in my experience. Yes.
Okay, perfect. Thank you very much, Sudersen. We'll just give the guys another minute or so to see if any more questions come through. But other than that, I think, thank you very much again, Sudersen, and I'm sure you'll get questions come through to your email. If not, the feedback's coming through, saying thank you very much as well, for a good PowerPoint presentation and good explanations and everything as well. So obviously you've got Sudersen's contact details there. You can download the presentation. Obviously the whole thing has been recorded, so it will be available on YouTube, on our YouTube channel, which I'll be able to send out to everyone's email address, and obviously it'll be there on LinkedIn for all to see if you want to have a look again. But I don't have any more questions coming through, Sudersen, so I think that could be that. So thank you very much again. Great presentation. Thank you everyone who joined in as well. It's been great to have you, and there'll be plenty more where this comes from, using a variety of different topics, hopefully next time as well. Sudersen, hopefully you'll be back as well, hosting again for us on other topics.
Thanks for your time, Jake, and I'd like to raise my thanks and toast for everybody who joined and listened here. It was fun. Hope you guys got a bit of information and glance to this system. And thanks for your time. Thanks for watching. Thanks, Jake, for this amazing opportunity.
No problem.
All the word spreading that you did over the weeks. Thank you so much.
Perfect. Thank you, guys.
Have a nice day, guys.
Cheers.
Cheers. Bye.